Welcome to the deep dive. We're jumping straight into a core challenge with today's large language models,
hmm
making them feel like they truly get you.
Right.
You're interacting with these incredibly powerful AI, but sometimes the responses, they just land in a general ballpark, not really your personal sweet spot.
That's a really key point. Right now, a lot of the alignment, getting these models to do what we want, relies on reinforcement learning from human feedback, RLHF.
Hmm.
And a lot of research highlights that these systems often depend on, well, a single overarching reward system.
Like one size fits all.
Kind of, yeah.
Hmm.
It's a bit like trying to find one perfect spice mix that absolutely everyone loves. It just doesn't quite work.
And yeah, as anyone who's ordered pizza with friends knows, one size rarely fits all. It seems
Right.
the demand for AI that really understands individual needs is just growing.
Oh, absolutely. There's a definite shift highlighted in recent studies towards more adaptive, more personalized AI systems. People want AI that gets them.
But getting there isn't straightforward, right? What are the hurdles with the current ways we try to personalize?
Well, yeah, the current approaches definitely have limitations. Many try to categorize users based on pretty broad strokes like demographics,
And
you know,
alienage, location, that sort of thing.
exactly. Or maybe even personality traits, which some other work has explored. But people are just more complicated than that.
Yeah.
These categories, they often miss the subtle individual preferences that actually make the difference.
Okay, let's unpack that a bit. So you're saying trying to box people into these general groups, it might not capture what really makes my preferences unique compared to, say, yours.
Precisely. And, there were earlier attempts too, looking at hidden patterns, latent representations within the models or reward systems themselves.
Right, I've seen some papers on that.
But these methods often need a massive amount of data from each specific user.
Which just isn't always feasible, is it? Especially if you're new to a system, you don't want to spend weeks training it. So, given these hurdles, what's the fundamental challenge researchers have been bumping up against in making LLMs truly personal, and how are they trying to get past it?
I think that's the crucial question. Beyond just, crude categorization, a core problem has been efficiently capturing those nuances, individual tastes, without needing like a novel's worth of data from every single person.
Finding that balance.
Right. Traditional methods often struggle with that balance.
Okay, and that sounds like it leads us directly to this new approach you mentioned, low rank reward modeling, or LoRe.
It does us.
It sounds like it's aimed squarely at this problem efficient personalization, but with less user data. What's the sort of fundamental shift in thinking here?
So the core idea with lore is instead of learning a totally unique reward system from zero for every single user,
Which sounds daunting.
it is. Instead, it models individual preferences as different combinations, different mixes of a shared set of fundamental basis preferences.
Okay, hang on. Like musical notes, you have a limited set of notes, but infinite songs?
That's actually a great analogy. Think of it like that. There might be countless individual preferences, but maybe they draw from a smaller core set of underlying preference elements or dimensions.
Oh, okay, this is getting really interesting. So the AI first learns these sort of foundational preferences that lots of people might share in different ways.
Exactly. It learns this shared basis. And then for a new user, it only needs a little bit of feedback from them, maybe just a few examples of what they liked or didn't like.
Just a handful.
Yeah, potentially just a few. And it uses that to figure out the right mix of those basis preferences to create a personalized reward system just for that user.
Wow.
So it allows for much faster adaptation and it scales much better.
So the mission for us in this deep dive then is to really get under the hood of lore, understand how it pulls this off and why it might be such a big step towards AI that feels, intuitively right for each of us, even without tons of explicit training.
Let's do it.
Okay, let's get into the nuts and bolts.
Yeah.
How does lore actually work?
All right, so as we said, traditional RLHF usually trains this single reward function, aiming for general appeal. Lore takes a different path.
Mm-hmm.
It collaboratively learns this shared reward basis using preferences from a whole bunch of users. So instead of just one reward score, this basis generates multiple dimensions of reward. Let's call it B's dimensions.
Okay, so it's not just good, bad anymore. It's like good in what way? More nuanced.
Precisely. Much more multifaceted. And then each user gets their own unique small set of numbers. It's called a weight vector.
Right.
And that vector dictates how their individual preferences mix those B underlying reward dimensions together to get their personal score for response.
It's like we each have our own little mixing desk, adjusting the sliders for these fundamental reward frequencies to get the AI response that sounds best to us.
That's a really good way to put it, personal soundboard, yeah. And the beauty is, when a new user shows up, you don't have to retrain that whole foundation, that whole basis. You keep the basis fixed. You just need a small sample of the new user's preferences, what they like, what they don't, to figure out their specific weight vector, their personal settings on the soundboard.
And that makes the personalization part really efficient.
Remarkably efficient, yes.
Now, the research mentions a connection to collaborative ranking. How does that field influence LoRe?
Yeah, that's an interesting link. Collaborative ranking, which has been studied for a while, is basically about figuring out individual tastes from how lots of users interact with lots of items. Think movie ratings, product recommendations.
Right, even if I've only rated a few movies.
Exactly. Even if each user has only seen or rated a small fraction of the items, the key insight there is that often these preferences aren't totally random. They have an underlying structure, often called low rank.
Meaning they can be explained by fewer shared factors?
Precisely. Shared factors like genres or certain actors or styles.
And LoRe is basically taking that idea and applying it to LLMs. But the paper points out a challenge. The item space for LLMs is, well, enormous. Prompts, all the possible responses. How does LoRe handle that scale?
That is a critical point. Yeah, the number of possible prompt response pairs is astronomical. So LoRe tackles this by, instead of trying to learn preferences over every single possible output.
Which seems impossible.
Right. It models these diverse user preferences through that set of B basis reward functions we talked about. These functions take a prompt and a response and output that B-dimensional vector representing those core reward aspects.
Okay.
Then each user's preference is just that weighted sum using their personal weight vector.
Right.
So it's learning preferences over these lower dimensional basis rewards, not the infinite outputs.
Gotcha. Focusing on the core components, not the whole universe of options. That sounds way more manageable.
Exactly. And the research explores different ways to actually implement this reward basis, RFI.
Oh.
Well, one way is to use the internal representations, the embeddings, from an existing pre-trained reward model. Those already capture a lot of meaning.
Makes sense. Leverage what's already learned.
Right. And then you apply a simple, learnable, linear layer to project those rich embeddings down into that smaller B-dimensional basis space. Or they also suggest maybe using a shallow neural network for more flexibility, or even techniques like LoRa for parameter-efficient fine-tuning.
LoRa, okay. So adapting just parts of the existing model.
Yeah, adapting maybe the early layers of the reward model, but still getting that B-dimensional output. So there's flexibility in how you build that foundation.
Okay, so you've got the foundation, the basis rewards. What's the actual process then? How do you use LoRe to personalize an LLM for someone?
So it starts by gathering preference data. You get this from an initial group of, let's call them scene users.
The training group.
The training group, exactly. Each person provides examples. I prefer this response over that one for the same prompt. You collect all this data from everyone. Then, using this collective data, the system simultaneously learns two things. One, those basis reward functions, the RFI, and two, the individual preference weights for each of those scene users.
So it learns the building blocks and how the initial users combine them all at once?
All at once. The goal is basically to find the basis functions and the user weights that best explain all the preferences you observed in that initial group.
Okay, makes sense. And then the crucial part. How do you personalize for a new user, someone who wasn't in that first batch?
Right. This is where the few-shot magic happens. For a new user, that learned reward basis, it stays fixed. You don't touch it.
Don't retrain the foundation.
Nope. Then you just collect a small amount of preference feedback from this new person, maybe just a handful of examples of what they like and dislike.
Okay.
Using only that limited data, you then estimate their personal preference weight vector. You find the specific combination of those fixed basis rewards that best reflects their individual taste based on those few examples.
So the really heavy computation, figuring out the fundamental preferences that's done up front with the larger group, and then tailoring it to me just involves figuring out my unique recipe using a tiny bit of my data. That does sound incredibly efficient.
It is. It's a very clever separation of concerns.
Oh.
And the paper also discusses how LoRe could potentially plug into other frameworks once designed for, like, multi-objective alignment.
Multi-objective meaning?
Systems that try to generate responses that balance different goals simultaneously, like Maybe you want a response that's both highly informative and really concise,
Mm.
or helpful and harmless. Those can sometimes conflict.
Ah, okay. So if we connect this to the bigger picture, could lore help an AI tailor its response not just to my general style, but maybe to what matters most to me in the specific conversation? Like balancing helpfulness and humor differently depending on the context?
That's definitely the exciting potential, yes.
Yeah.
Because lore models personalize rewards as these combinations. It might be able to adapt to a user's implicit priorities, the trade-offs they naturally make, without them having to explicitly say, okay, now give me 70% informative and 30% concise.
The AI learns your priorities through interaction.
Exactly. It learns your nuanced trade-offs over time.
Now, the research compares lore pretty directly to some other methods, PO and VPL. Can you quickly outline the main differences and why lore might have an edge?
Sure. So some other methods, as we touched on, either explicitly group users, or they might train separate models per user, which can struggle with those fine-grained preferences, or generalizing to new people with limited data.
Right.
PL tries to learn sort of prototype preference points in a representation space. VPL uses an encoder to map user preference data into a kind of latent code, a hidden representation.
And the issues there were PL might not cover all possible preferences well, and VPL often needs quite a bit of data per user and doesn't always transfer well to new people.
It's exactly right. LoRe, on the other hand, directly learns that compact set of basis reward functions. This separation, learning the basis first, then the user-specific weights, seems key
Why is that separation so important?
because it allows for that really rapid personalization with very little data for new users. You're just learning a small weight vector, not a whole complex representation. It also seems to generalize better than those latent code approaches.
It's more efficient, too.
Yes, significantly. LoRe generally requires fewer trainable parameters than something like PL or VPL, which makes it more efficient to train and potentially scale to, millions of users.
Okay, and the proof is in the pudding, right?
Mm.
The paper presents experimental results. They tested lore on different datasets, Personal LLM, Reddit TLDR, Prism. What did they find? Did it hold up?
It seems to have held up very well. Yeah, across these different data sets, which represent different kinds of tasks and preference diversity, LoRe consistently did a better job at generalizing, both to users it had seen during training and to completely new, unseen users.
So it learned better and transferred better.
That's what the results suggest. For instance, in the personal LM dataset, even when they varied how diverse the user preferences were, LoRe generally outperformed the baseline methods in accuracy. Same story on the Reddit TLDR dataset. Higher accuracy in predicting user choices, even with limited initial training data.
And what about Prism? That sounds like a tough one. Real-world preferences, diverse users globally.
Yeah, Prism is a good stress test.
And again, lore showed really robust performance there, achieving the highest accuracy compared to the other methods. What's quite telling is that Prism actually has a relatively small number of interactions recorded per user. But even with that sparse data, lore was apparently able to learn personalized preferences effectively and generalize well. Some other methods, like VPL and PAL, reportedly showed signs of struggling to scale or adapt as well in that setting.
Did they look specifically at how much data from a new user helps, that few-shot aspect?
They did. They checked how performance changed as you gave lore more examples from a new user, say, going from 1 example to 4 to 8.
Did more data help lore more? Yes. For lore, the accuracy for new users consistently improved as the number of few-shot examples went up across all the data sets. But interestingly, the performance of VPL and PL didn't show that same steady improvement with more few-shot data.
What does that imply?
It suggests that lore's way of representing preferences, with a fixed basis and adaptable weights, might be better suited to actually using that additional feedback from new users effectively. It really highlights lore's strength in leveraging even small amounts of new data.
Okay, so let's try and wrap our heads around the core innovation here. To recap lore, it learns a kind of foundational dictionary of reward preferences, the basis. And then for each user, it figures out their unique recipe using just a little bit of their feedback.
Spot on.
And this gets around needing rigid categories or needing, tons and tons of data for every single person.
Exactly. And the key advantages that the research really points to are, 1, better generalization, especially to new users it hasn't seen. 2, that efficient learning with limited data, the few-shot adaptation. Crucial. And 3, the potential to integrate with more complex systems that need to balance multiple objectives for more nuanced outputs. The results across those diverse datasets really seem to back this up, showing it outperforming other methods. Plus, that parameter efficiency we mentioned is a big practical win.
So, bringing it back to you, the listener, what does this all mean? Well, imagine a future where your AI tools, your assistants, they truly get you. They understand your little quirks, your specific needs, your style, even after just a short time interacting.
Hmm.
LoRe feels like a significant stride towards that future, moving away from generic one-size-fits-all AI towards something that feels genuinely personalized.
Absolutely. And just as a final thought, the research does mention looking into using lore in like real-time learning scenarios,
Continuously adapting.
continuously adapting.
Yeah.
So what might that look like? An AI that's constantly fine-tuning its understanding of your preferences moment by moment as you interact with it.
Wow. That opens up some fascinating possibilities and maybe some questions too about how that evolving relationship between us and AI might look. Definitely something to chew on.